Hello, everybody. Today we're going to be covering classes and error handling in Python. Let's go ahead and get started. So the first thing to know when it comes to classes is we need to talk about the background of object-oriented programming. So in Python, just about everything is considered an object. Objects have properties and attributes as well as methods. And we've seen some of these methods before whenever we're dealing with certain other objects. So properties are like variables that are a part of an object, and they are only referenceable through the object using dot notation. So we can see in this example here, I have an example class object that I've created here, and then I'm using the dot notation to reference its property one. So this object has a property called property one. And when I reference that property one using dot notation, we see that I get an output one here to the console. And if I create and then if I also reference its property two, so again, using dot notation, this object has a property called property two. So example class object dot property two. So I'm getting the property two from the example class object. That outputs to the console as an A, because that's what its property two is. And then again, for property three, example class object dot property three. So this example class object has a third property. The name of that property is property three, and we can reference that property object using dot notation here. And when I do that, this outputs a list. So essentially what's happening here is that property one has the value one in it. Property two of this object has the value A stored in it, and property three of this object has an empty list stored in it. And we can reference all of those properties using dot notation. This is just a coincidence here that this one happens to have three properties. It could have just one property, it could have multiple, and the names can be dynamic as well. So the names that I chose here, this was just for demonstration purposes to show that this is a property, this is also a property, and this is a property. But we can see, we'll see in a few minutes here just how we can set property names dynamically, and then we would reference those property names using a different value here. So methods are like functions that are defined within and called on an object using dot notation. So we've heard of this before, where we call a method on an object. So when you think of a list object, so here I've created a list and I've called it my list object. And in that list object, I've stored the values 1, 2, 3, and 4. And then, and as mentioned, just about anything in Python is an object. So lists are also objects. It's kind of, you can think of it like the list object, the list data type has, or the list data structure has obtained properties of an object. So it's like a child class of an object. So it's inherited all of the properties of an object here. So right now I'm just creating a my list object, storing 1, 2, 3, 4 in that list. And now I can call the reverse method on that list object using dot notation. And now when I output my list object again, now it's that same list, but reversed. So this is essentially a function that, that is kind of part of the list object. So all list objects can use this reverse method, and you call it on that list object using dot notation. So we're saying to reverse the my list object here. And remember that one of the key differences here is that a property doesn't have parentheses at the end here. So you see this just ends with dot property one, no parentheses at the end. That indicates that this is a property. And then in this particular case where we have the parentheses at the end for this method name, that indicates that this is a method. And if this method accepted parameters, they would go in there, but reverse doesn't. Reverse just has its stored functionality for taking the existing list and flipping it, essentially. So now on to classes. A class is essentially a template that is used to define a custom object type, its properties and attributes, its methods, and its behaviors. Classes are defined using the class keyword, and we'll see that here in a second. And properties and attributes and methods of a class are indented underneath the class declaration. So just like with many other things in Python, we use indentation for determining what's part of the parent structure here. So in this case, it's a class, but as we've seen in the past with functions functions, the code that executes as part of that function is indented underneath that function with an if statement. Code that's executed as part of that conditional is indented underneath that conditional, etc. So the same thing holds true for classes. So in this particular case, I'm creating an example class. So I've declared it using our class keyword, and then I've named my class here example class. Something you'll notice here is that I'm using camel case, starting out with capital E, and then the next word for class here, I have a capital there. So this is the convention for when you're naming classes. Typically, classes are going to follow camel case. We've seen in the past when we create variables, we'll use snake case, where we have everything in lowercase and underscores in between the different words in that variable name. But when you're defining a class, you want to follow the convention of camel case here, and that helps us to distinguish the difference between a class and a simple variable. So this class has 3 properties, and I've defined those 3 properties here. We have property 1, and it's just always going to be equal to 1. Property 2, always equal to the string A, and property 3, which is always equal to a list. So as mentioned here, this is the name of the class. So whenever I want to reference this class or create an object of this class, I'll use this class name up here. And then these are properties of that class. So anytime I create an instance of this example class, it will have these properties included in it. Now, this is a really simple class here. It only has these 3 properties, and they're hard-coded as 1A and a list. This isn't typically going to be the case, but just for example purposes, this is the simplest type of object you could create, or the simplest type of class, sorry, that you could create. You just have the class keyword, the class name, and then the properties that are part of that class. So we can create instances of a class by calling the class name followed by parentheses. So as we saw in the previous slide, I had an example class object. And the way I had created that example class object was with this line of code right here. So this line of code right here, what I'm doing is I'm creating an example class object variable, and stored inside that variable using the assignment operator here, I'm assigning it to an instance of the example class. So I'm referencing this example class up here, and you'll notice I'm putting the parentheses after it here. The parentheses after it here specify that it needs to be an instance of that class rather than the class itself. If I didn't include the parentheses, it'd be basically creating a class, like a duplicate reference of that class. But here I'm creating an instance of that class using the parentheses after here. And then what happens here is we can reference the properties just like we saw in the previous slide of that class using dot notation. So this is the same screenshot that I showed on the previous slide. So what we have here is we have the same example class object that I've created up here, but right now I'm just referencing the properties. So now this kind of brings it full circle to what we saw on the previous slide, where the previous slide I was just showing this screenshot to show how objects have properties. But in this slide here, I've showed how I created the class and then how I created an instance of that class. So this is just a single instance of the example class. And then I've referenced all the properties of that example class in the screenshot down here using dot notation again. So anytime we want to reference, so basically what I'm doing here is I have my example class object. I use my dot notation to get property 1 there. And what this does is it looks in the example class and it retrieves property 1 of that object there. Here I've hard coded it as property 1 always equaling 1. So we're going to get 1 returned there. And then and then for property 2, it'll return A, again using dot notation, no parentheses after because this isn't a method, it's simply an attribute. And then for property 3, it's a list. So that's how we can define a class, create an instance of a class, and then reference the various attributes of that class. So now the class that I created previously, it works, but it's really not the best practice for creating a class, because what I was doing there is I just had my class and then I just had property 1, 2, and 3. So here I just created this example class and I just assigned the properties immediately here. But that's not typically what we're going to do when we actually create our own classes, because we want them to be more dynamic and make it so that the property values can change or be instantiated differently based on or in different instances of that class. So to do that, we're going to use the init method. So every class has an init function inside of it. It's essentially a method, but it's not one that you're actually going to call on your object when you create the object. So it's sometimes better to just think of it as a function. Something you'll see here is that it kind of shows up in this purple color here, and that's showing the special nature of the init function. So anytime you have this like double underscore here, and that's an important thing to note, you have a double underscore init double underscore. It looks like a smooth line in PyCharm, but really those are two underscores there. So anytime you create a class, you'll typically want to have an init function within there so that whenever you create an instance of that class, this init function is run. And what this init function is doing is, so first off, it's just like another function or a method, and we have to instantiate that using the def keyword. And then we give the name, and in this case, it's the special name init, double underscore init, double underscore. And then self goes in the parentheses here. And we'll talk a little bit more about self in a future slide. So just hang in there. And then inside of this init function, what I'm doing is I'm setting, just like with the previous class, I'm setting property 1 equal to 1, property 2 equal to A, and property 3 equal to an empty list. This will essentially create the same type of object as I was creating on the previous slide. If I did another example object class, or example class object, it would have the same exact properties. If I go back to this slide after creating, so say I create my class using this code here instead of the code that's on the previous slide, and then I create an instance of that class here. So I create an object from that class, and then I call the different properties or reference the different properties of that object. It would be the same thing. So we can kind of replace this code here with this code here, and it's essentially going to do the same thing. So yeah, this is essentially the same as the class definition from the previous slide, but using init instead of just having these properties hard coded above at the same level as where this init function is going. So we use the init function to dynamically assign the values of the new object instance properties. So we use the init function to dynamically assign the values of the new object instances properties. So in this particular case down here, now I've updated my example class, and I've made my init function accept some additional parameters here. So now it accepts the parameters A, B, and C here. And then what I'm doing inside of my init function is I'm setting property 1 equal to A, property 2 equal to B, and property 3 equal to C. So now when I create an instance of my example class object, now I'm going to call it example class object 2. Now those parentheses aren't empty. So on the previous slide, the parentheses were empty because there were no extra parameters coming in here. And there wasn't even an init function, so there wasn't a way to pass additional parameters there. So here I'm passing some additional parameters, and what I'm passing is to the letter B, and then an empty set or an empty dictionary, hard to say without actually populating it with any values. But yeah, so I'm passing those things as the 3 parameters here. And so what's happening is 2 is being passed as A, B is the letter B is being passed as B in the init here, and this empty dictionary is being passed as the letter C here. So now when we, and then that's A is assigned to property 1, B is assigned to property 2, and C is assigned to property 3. So now when I take my example class object 2 and I obtain the property 1 property from, or attribute from that object, using dot notation, now I get 2 back because it stored the 2 in property 1 over here as part of my init function. When I get property 2, the value B is returned there because I passed B as the second argument here, which corresponds to the same B over here, which is assigned to property 2 in our init function. And then if I get property 3, that's going to be the empty dictionary because that's the third thing I passed, which C is the third argument here, and then C is what's assigned to property 3. So that's how we get the empty dictionary there. Now, I could create multiple instances of my example class if I wanted to, and I could pass in a bunch of different values for A, B, and C here. And it would basically assign property 1, 2, and 3 according to the order that I pass here. Because remember from functions last week, we need to make sure that the order that we pass aligns basically with what the signature of our function is. So in this case, we're doing A, B, and C. So something you'll notice here is that we don't include the self parameter when we instantiate the class. So again, we'll be talking about self pretty soon here, but when you create an instance of the class, you don't include the self parameter. But when you create the init function, you do need to include the self parameter because the self parameter is referenced within the init function. And we'll talk more about self here in a bit, but just know that whenever you create an init function, you're always going to want to start with self, and then after that comes the parameters that you'll use for dynamically setting the properties of your object. So methods. Methods are like functions that are defined within and called on an object using dot notation. So we define methods just like functions, except they are indented underneath a class. So here we have I've created a class and I've called it user. So in my user class, I have my init method or function here. So my init on my user class, it accepts, so of course the self argument, we'll talk more about that here shortly. And then it accepts name, age, occupation, and location. And what happens in this init is that you'll have to pass a name and age and occupation and a location every time you're creating a user object, and then it would assign the name that's passed to the name property, the age that's passed to the object's age property, the occupation that's passed to the occupation property, and the location that's passed to the object's location property. So these all only reference the specific instance of the class. And whenever you create an instance of a class, that's considered an object, and that object will can and often does have unique values from other instances of the same class. Now there are two methods that I've defined on this class. One of the methods is called introduce self, and this just accepts a single parameter. Self, again, any method that's defined underneath a class, the first argument is always going to be the self parameter here. And again, we'll get to that soon. Just don't worry about it too much right now. But what's happening in this introduce self function or method is that when it's invoked on the user, on an instance of the user object, then it's just going to print out hello, my name is, and then self.name. So we're referencing the current instance of the object's name, and so it would output whatever the name is assigned for the current instance of the object. And then I have another method defined here. So just like a function, we use the def keyword, then we name our method here, describe self, and then the self parameter must be passed to any method. It'll always be the first parameter. And then here, what I'm going to do is I'm calling self.introduce self. So what I'm basically saying here is invoke this user object's introduce self function first as part of describe self. So the first thing that's going to happen in describe self is introduce self will be invoked. And notice nothing's passed here because the only parameter there is self. So there's no need to pass anything there. You kind of ignore self when you're actually invoking a method, or whenever you're invoking a method on an object, you just ignore the self parameter. So here I'm just doing self.introduce self. So the current object that we're referencing when I call the describe self, we want to invoke the introduce self method of that object. So that's going to output hello, my name is, and then plus whatever the name of the current instance of the object is. And then it's also going to print I am blank years old and work as a blank in blank. And string formatting that we talked briefly about last week. If you missed last week's lecture, please go back and read that. It's going to be, or check that out. It's going to be very important for understanding classes here. So I'm formatting an age for this first set of squiggly brackets here. So and then occupation for the second set of squiggly brackets, and location for the third set of brackets here. So say that the object's age is 10, their occupation is programmer, and they live in Colorado, then it would say, I am 10 years old and work as a programmer in Colorado. And we'll see that here in a second. So up here, just to call out again, these are the properties. We typically define properties within the init function. So this user object has 4 properties: the name property, the age property, the occupation property, and the location property. And then down here, I'm defining 2 methods on this user class. So every instance of a user class will have these 2 methods: introduce self and describe self. And typically what you'll have here is you'll have your init up at the top, and then after your init is when you would define your other methods, your non-init methods for that function. So here, what I've done is I'm creating a user variable, and that user variable is going to store an instance of a user object, or an instance of the user class, which will be a user object. So here I call user, because that's the name of my class, and then I pass in parentheses the various things that go into the init function here. So first is the name, so the name is David. The age is 27. The occupation, so data engineer, and then the location, and that's Colorado, USA. So I'm basically creating a user object that represents myself. My name's David, I'm 27, I'm a data engineer, and I live in Colorado, USA. So now what I can do is I can invoke this user method on, I can invoke the introduce self method on my user object. So I have, my user object here, reference the name of the object, and then dot. So I'm calling the introduce self method on my user object using dot notation, and then introduce self. Again, introduce self doesn't require any parameters, because all that's passed is self, which is basically a reference to the current instance of the object. And then what we see output here is, hello, my name is David, because I've instantiated my user object to have the name David. And then what happens in here is printing, hello, my name is the current instance of the object's dot name. And since my user object, this current instance's name is David, we just see, hello, my name is David printed to the console. And now for the user describe self, and I'm not going to be moving my mouse around here because that thing keeps popping up. But now I can also call the user describe self, or the describe self method on my user object using dot notation. And what that's going to do is it first calls the self dot introduce self. So we first see it say, hello, my name is David, because in here I'm referencing the introduce self method. And then I'm going to print out, hello, my name is David, because of that. So it's kind of like you can kind of substitute self here for this user object that this describe self was called on. So you can kind of think of it as like, it's basically internally calling user.introduce self. And so that's why we see the same output that we got up here. And then in addition to that, it prints out, I am 27 years old and work as a data engineer in Colorado, USA. And that's because I assigned, when I created the object, the age was 27, the occupation, data engineer, and the location was Colorado, USA. So you can kind of think of, anytime you see self, it's almost like referring to this variable here. So like when I call the user.describe self, it's almost like a user.age, user.occupation, user.location is kind of how you can think about it there. All right, cool. So now let's dive a little bit deeper into the self parameter. So self refers to the current instance of the class, and we use it throughout the class definition to access the class's properties and methods. So basically, self must be the first, and as mentioned already, self must be the first parameter in every class method and can be optionally followed by other parameters. So when I defined my user class here, self, you'll see here I have self in my init. It's the first argument to init, it's the first argument to introduce self, and it's the first argument to describe self. I can follow it up with additional parameters. So when I'm initializing a user object, I'm following that up with 4 additional parameters, namely name, age, occupation, and location. So those 4 parameters would be required anytime you create an instance of a user object. And then if I want to, call the introduce self to method, the first argument has to be self here, and then I can pass additional arguments after that self argument. So now I've updated this method to introduce self to. So it's no longer just introduce self, it's introducing self to. So like I'm introducing myself to somebody else. And the other that I'm introducing myself to is this parameter that's passed here. And then in this function, it would print hello to the other person's name, my name is, and then my name, the self.name, so the current object's name. I guess I shouldn't say the current object's name. And then there's also the describe self to. It's very similar to the introduce self to in that now I'm instead of just describing myself or describing self, the object is now describing itself to someone or something else. So here it's doing the self.introduce self to, and all that's passed there is the other parameter. So we get this other parameter that was passed in to the describe self to method, and we're also passing that to the introduce self to method, so that it would say hello, whatever the other's name is, and then my name is, and then the self objects, the current instance of the user object's name. And then it'll still output the I am blank years old and work as a blank in blank. So again, just to reiterate, it's always worth re-mentioning. This is where we define our properties. We define our properties within the init function. So we have a name, an age, an occupation, and a location. These are all properties of the user class. So every instance of the user class, every object created from the user class will have name, age, occupation, and location attributes. And then we're defining our methods down here. Now they're introduce self to. Introduce self to takes the self parameter, of course, but then also an additional other parameter which must be provided. And then same goes for describe self to. There's another other parameter that must be provided there. So now if I create that same user object that I had created before, still same parameters passed there. The name is David, the age is 27, data engineer is the occupation, and the Colorado, USA is that user object's location. But now I want to introduce my user object to someone else. So I call the introduce self to method on my user object using dot notation. And because the introduce self to method accepts another parameter called other here, I now have to pass a string or some parameter into the user.introduce self to, because remember, we don't have to pass self, but we do have to pass whatever other parameters are passed there. So now here I'm passing the name Zofia there, and so the program outputs, hello Zofia, my name is David. So it's like the object is introducing itself to another person or thing named Zofia. So something that just helps here, all the references to self throughout. So self is always going to be the first argument to every method within our class. So self is the first argument to init, self is the first argument to introduce self to, and self is the first argument to describe self to. So you'll always want to use self there. Now, you can give it a different name if you want. Don't. You can, but just don't. Whenever you're creating these a class in Python, it'll automatically include the self parameter there for you. Don't rename it. It can cause a lot of confusion for everybody, especially if someone's trying to read your code. But then what's basically happening here in the init is it takes self for the first thing, and what it's doing in the init is it's initializing the current instance of the user object's name as the name passed in the parameters up here, assigning the current instance of the object that's being created's age property to the age that's passed. Same goes for the object's occupation. It's assigning it to the occupation that's passed. And then the object that's being created's location is assigning it to the location parameter that's passed. And then in here, we have the self parameter for introduce self to, and then we can reference the current instance of the object's name. So we're referencing that current instance of the object's name attribute here, and that's what will be inserted to these curly brackets here, since that's the second argument to format, and this is our second set of curly brackets there. And then same goes for describe self2. So now I can call the introduce self2 in the describe self2 using the self parameter here. So I'm saying like the current object that I'm referring to, call that current object's introduce self2 method, passing other to that method. And then also printing out all this good stuff here and referencing the current instance of the object's age, the current instance of the object's occupation, and the current instance of the object's location for formatting into this string here. So yeah, we're referencing the object's own properties in these particular cases here. So the object's own name, the object's own age, the object's own occupation, and the object's own location. Here I'm referencing the object's own method, introduce self2. So so that's where that self comes in there. I'm taking the current object's own method, introduce self2, and invoking that. And then all of my external parameters here. So other. So in this particular case, I did user.introduce self2 Zofia. So that other was passed here, and then it's inserted down here into the format, which formats it into the string here. So it'll say, hello, Zofia. And then my name is, and whatever the object's name is in this particular case, the object's name is David because that's what was passed in the init. Cool. So doc strings, just like with functions, classes, and methods, can and should include doc strings. So I wasn't including them before this point, but now I'm going to go ahead and add those in because this is important to include so that anybody who tries to use my user class can easily see some documentation on my user class. So this user class is my description of it is an abstract representation of a user. So this is the class docstring here, and in it I include the abstract representation of a user, so the description of my class, and then I include a reference to the various properties of my class. So I have properties, name, it's a string name of the user. My age property, it's an integer representing how old the user is. The occupation is a string occupation of the user. The location is a string approximate geographical location of the user. So something you want to include here whenever you're calling out your properties is generally what the data type is, or data types, supported data types for that parameter name, and then a short description of what it is. You need to also include a description of your user or of your class generally up here, a brief description. And then our methods can also have doc strings. So down here, I have a method doc string. Just like with functions, we want to include the same things that a function doc string would include. So remember, any function must have at least a description. So here I have introduces the user object to someone or something. So that's the description of the introduce self2 method. And then this accepts one argument. So it appears to accept two up here, and that's the self and other. But remember, self is always going to be the case with any method. Any developer should know that any method will always accept self as the first argument. And one of the things here is you don't want to confuse users and make them think that they need to pass two parameters, because you don't. When you invoke this introduce self2 function, you only have to pass a single parameter for other, because self is kind of implied. The self is like implied as a reference to the current instance of that object. So the arguments that you pass here, so I call out that the args are other. There's one parameter, it's other. It's a string name of the person or thing to introduce self to. And then we see that used down in here in our function. So just like functions, we want to include doc strings on our class, and we want to include doc strings on our methods as well, so that people can easily read about what our class is and what the methods do within that class. And just like with functions, you can do the same double underscore doc. So the instance of the object double underscore doc. to understand what the object or what the docstring is for that object or for that class, and the docstring is for that method. Just remember, don't include the parentheses whenever you're trying to get the docstring. So if I wanted to get the docstring here, I'd do like user dot double underscore doc double underscore. I wouldn't do user parenthesis double underscore doc double underscore. And same goes for introduce self too. And if you're wondering what exactly is meant by that, just go ahead and check back on last week's lecture for functions, and that should help clear things up there for what I mean with not including the parentheses when you're trying to get a docstring. All right, now the other topic we're covering this week, aside from classes, is errors and exceptions. So we're going to start with a syntax error. So a syntax error occurs when the syntax or structure and composition of the code written is invalid. So you've likely seen these while attempting assignments and you forgot a piece of punctuation, like you're trying to create a conditional or a loop and you forget to include a colon at the end of the conditional or of the loop definition, or if you misuse an operator, like say you're trying to, maybe in the first assignment when you were trying to add a number or concatenate a string to a number. If you didn't cast that number to a string first, you would have seen an error, a syntax error specifically. So when this occurs, when a syntax error occurs, a traceback is output to the console to help point out the error and a few different details on it. So here is the instance of forgetting a piece of punctuation. So I have while true, and I didn't include my colon after the true here. Remember, whenever you create a loop or a conditional, you should have the colon after your. So in this particular case, for a while, you want your colon after your Boolean expression here. It's not an expression. I just included a Boolean here, but I should still have a colon here nonetheless. But I don't. And because I don't have that colon here, when I try to run that code, I get this traceback output here that says file input line 1 while true, syntax error, invalid syntax. And so what this is kind of pointing out is it's saying that there's a syntax error in my code. I created some invalid syntax, and this caret here is pointing to about where in my code the problem is. So right now it's pointing to the E in true. The problem here, what it's kind of pointing out is you're missing something after true here. And then for this example over here, I'm misusing an operator. So if I wanted to check in my if statement, if X is equal to Y, I really should use the double equal sign. But here I'm not using the double equal sign, which is the equality operator. I'm instead using a single equal sign, which is the assignment operator. So this is the wrong operator for a Boolean expression here. You can't do an assignment operation in a Boolean expression. So I'm misusing that here. I wanted to determine equality and only print X and Y are equal if they are equal to each other, but I forgot my second equal sign. So when I run that code, I get a syntax error here telling me I have some invalid syntax. It's telling me that it's my file input at line 1. And it points out the line of code that's incorrect. So if X equals Y, and the caret here is pointing to where I messed up. So it's pointing to that single equal sign right there. It would be pointing to a double. So this is basically pointing out that it should be a double equal sign here. I'm using an assignment operator in place of an equality operator. I can't use an assignment operator in an if statement where I'm expecting a Boolean expression. So I get a syntax error there. So all this red output here in both of these cases, it's called a traceback, and the traceback tells you the file name and line number. So here, because I was executing it in the Python REPL console, it just says the file name is input. So it's the file name and line number is more useful when it occurs in a script because it'll tell you exactly what line the error occurred on and what the file name where the error occurred is. But in this case, because I'm just using the REPL environment, it just says file input, and it's line 1 because this was the first line in my REPL environment here. And then the error that occurred. So down here, we see that the error that occurred is a syntax error, and there's a message after that syntax error saying that I have invalid syntax. Same goes over here. And it uses the caret symbol to point to about where the error occurred. So here we see, so in this one over here, we see that the caret's pointing to the end of true. So it's not exactly pointing to right after true. It's not showing me that I'm missing something right after true, but it's pretty close because what I'm missing here is I'm missing a colon. So so it's kind of pointing out that I'm missing something near the word true. And then the caret here is pointing to my equal sign. That's pointing directly at where I messed up. It's telling me like, hey, this is the wrong operator here, essentially. This, you can't use an assignment operator here. This is where your problem is. So the traceback can be extremely helpful for telling you where you went wrong and give you kind of a hint for what you might be able to, for what you need to do to fix your code. So an important thing to note about syntax errors is that they are detected before execution and are always fatal to the program, meaning you cannot successfully run a program that contains such an error, even if that line of code is never reached. So if you write any code with a syntax error, you can't run that line of code successfully, even if that line of code is never reached. So you can write a file that has a syntax error in it, and that's perfectly acceptable until you try to run it. If it has a syntax error in it when you try to run it, it's going to fail even if that line of code isn't actually executed. So here I've created an if statement and I just have if false. So my if false, really, it shouldn't output anything down here, right? Like this line of code, line 46, will never be executed because I'm saying if false. The only way that lines 46 and 47 would ever be executed is if this evaluated to true. It won't. So these lines of code will never actually be executed. You can see also PyCharm kind of calls out that I did something wrong here. It's got it underlined in red. So PyCharm knows that I did something wrong here, but say I didn't notice that, or say I wasn't using an intelligent IDE and I was just using a text editor, and that text editor doesn't call out that I have an error here, and then I try to run my code. So if I try to run my code, now it'll say file, and it gives the file name. So this happened to be in, so, you know, it gives the path to the file. It happened to be in my demo3.py file. And it was in line 46 of my code. So if we look back over here, see line 46, that's exactly where this if x single equals sign y is occurring. And then it again prints out the line of code that was erroneous, and it shows if x equals y, or if x equal y. So again, assignment operator, so not the correct use of that operator. And the caret's pointing out exactly what's wrong there, and it says syntax error, invalid syntax. So even though this line of code was never actually executed in this, I still end up with a syntax error because I can't run a program that has a syntax error. There are other types of exceptions, which we'll talk about in a second, that's not necessarily true. You can have an exception in your code, and as long as that exception is never reached, the program will still run just fine. But with a syntax error, your program will always exit. It'll always fail if you have a syntax error and you try to run your program. And one other thing to call out here is typically what we've seen so far, whenever it runs successfully, we'll see a process finished with exit code 0. So exit code 0 means that it ran successfully. Any other exit code means that there was some sort of error that happened here. So we'll see here that process finished with exit code 1. So that just means that the program did not finish successfully. You can see a bunch of different other error codes out there, but in this particular case, the error that we see, or the error code that we see, is 1. So that's another way to see that something didn't execute quite right. All right, so errors and exceptions continued. So we just talked about syntax errors, and now we're on to exceptions. So exceptions are essentially errors that occur due to flaws in the program's logic. So you've likely seen an exception when attempting an assignment if you've ever tried to concatenate a number to a string but forgot to cast that number to a string first. So if you don't, if you try to cast a number, or if you try to concatenate the two like I do here, so I have if true, so this will always execute, this will always evaluate to true. Then on line 47, I'm trying to print hello plus 1. One is an integer, hello is a string. So so Python doesn't know what to do with this plus operator here. So the plus operator is It's used for addition when you're adding two numbers together, and it's used for concatenation when you're adding two strings together. But we get a conflict here if we try to add together a string and a number because it doesn't know which one to use, basically, concatenation or addition. So this illogical code is executed, so a type error exception occurs. So when I run this, line 47 will run because I just have if true. So since this is set to true, this line will always execute. So then when I run that, I get this traceback here. Again, it calls out my file, and it says on line 47, my problematic code is print hello +1. And then I get a type error here, can only concatenate stir, not int to stir. So basically what it's saying here is it's trying to use this as a concatenation operator, but I can't concatenate an integer to a string. I can only concatenate a string to another string. So I would have to first cast my 1 to a string if I do want this concatenation operation to succeed. And then I get my process finished with exit code 1 here. So exceptions are only detected while the program is executing. So this is different from syntax errors. They're only detected while the program is executing. So you can still run a program that may raise an exception, and you will only see an error occur if the code which produces the exception is actually executed. So in this particular case here, I've now updated this if statement up here to have if false instead of if true. So now this line 47, will never execute. And PyCharm kind of knows this and has highlighted it in yellow saying like, hey, this line of code is pointless. It's inside of a if false, so that'll never execute. PyCharm also recognized up here that I was doing something wrong here, and that's why the 1 is highlighted. So PyCharm is really helpful in this respect for calling out when something might be wrong. But in this particular case, so I have if false, so line 47 will never execute. So because line 47 will never execute, the illogical code is not reached, so the program runs successfully. So now when I execute that, I just see the print after conditional here, and I get a process finished with exit code 0, meaning that everything worked correctly. So if you look up here at this one, I have my print after conditional. It never printed after conditional to the console. It just immediately errored out and it exited the program. So any code that was after the code that raised an exception, that code is never executed, never evaluated, so we never see the output here. But in this particular case, even though I have a code that would produce an exception, because that code was never executed, an exception never occurs. So we execute line 46. We don't execute line 47 because this evaluated to false. So we kind of skip that. Then we come down to here and we print after conditional. So we see that output at the console there, and everything runs smoothly. We get an exit code 0. So exceptions only cause an issue if the erroneous line of code is actually reached. Whereas, with a syntax error, regardless of if that line of code is reached, if you have bad syntax, you're going to get an error. So there are many different built-in exceptions that can occur. Too many to go over in depth here, but common ones that you'll see include type errors, index errors, key errors, indentation errors, and value errors. And highly recommend looking those up on your own time in the additional resources that I've provided at the end of the slides here. I have a link to the various built-in errors or exceptions that you'll see in Python. Definitely worth looking into. You'll see them in time. So as you see them, maybe research them or look into them ahead of time. Cool. So exception handling. So up to this point, encountering an exception has meant our program stops execution and cannot proceed further. We can get around this by integrating exception handling into our code base, where we essentially anticipate potential errors and include the necessary logic to address these errors so that the program execution can continue. So the key control structure that you're going to want to use for exception handling is called a try except. And you'll often see it denoted as try ... except. So the try except is a control structure that allows you to try some lines of code and catch exceptions that might occur in that code so that we can handle them as needed. So in this example here, I've used my try except. So I've set x equals 10, and I've set my 10 as a string here. And now what I want to do is I want to try this line of code. I want to try to print 9 plus my x value here. And then I have my except down here. And this except is basically set to accept any exception. So it'll catch any exception that occurs. And it's just going to, instead of failing the program, it's just going to print an exception occurred. And then the program will exit successfully because that exception was caught, it was handled, and then we didn't continue to raise the exception, so we won't see an error in our code. So here I have the try. Below the try, indented underneath the try, I have the code that I want to try to execute. And then underneath my except, indented there, I have the code to run if an exception occurs in the code that I'm trying in my try block. So if an exception occurs up here, then in the except block, this is what we'll execute. So it's like this except block catches an exception that happens here, and then it does whatever in the except block. So now if I run this, I get an exception occurred. And that's because we're going to get that same error that we basically saw on the previous slides where I'm trying to add together a string and an integer. We know that's not allowed. So we get an exception there. We get an error. But instead of getting an exit code 1 and getting a traceback and all the errors and an error and all that good stuff, we just get an exception occurred because we tried this code, it failed, an exception was raised, but then that exception was caught by this except block, and then the code inside the except block is executed, and it just prints out an exception occurred, and we see that printed to the console here, and then process finished with exit code 0. So it exited successfully. We successfully handled our exception. So notice we get an exit code 0, meaning the program ran successfully, no exceptions. So an exception did occur, but we handled it. We caught it in our except block, and we did something about it, and we just printed an exception occurred. So we can include as many except blocks as needed in a try except for handling different exceptions in different ways. These are evaluated in order, with exception being the broadest possible exception, and exception with a capital E here, that's the broadest possible exception that can be produced. Every exception is basically a subtype of the broad exception class. So here I've updated my code so that now I have multiple except blocks. So in these multiple except blocks, I have my first except block is a type error, and I'm accepting a type error as TE, and then I print a type error occurred, and then I add the string version of my type error here so that it'll print out the string version of the type error. In my second one, I'm accepting a value error, so I'm catching value errors in the second except block, and I'm catching those as VE, and then I can reference that inside of my code or inside of that except block, and then there I would print a value error occurred and output what the value error is. And then finally, I have like a catch-all block at the end, which is accept exception as E, and then I'm printing an unexpected error occurred, and then just outputting what that unexpected error is. Something you'll notice in the bottom, I have that last except block is accept exception as E. That's almost like the same thing as what I'm doing up here, where I just have an accept. This accept is just accepting all exceptions, but instead of doing an as, the as allows me to reference that exception inside of the accept block. So I can reference the exception itself inside of my accept block here and then do something with it. So in this particular case, I'm outputting it to the console. I'm printing it to the console so I can see the details of that exception. So here in the green box, I'm boxing in the exception type that I'm trying to capture in that particular accept block. So I'm catching in the first block, I'm catching a type error. In the second block, I'm catching value errors, and in the final block, I'm catching all exceptions. So the broadest type of exception. So if a type error occurs, we'll come in here. If a value error occurs, then we'll come in here. If any exception other than a type error or a value error occurs, then it'll go into that final except block at the bottom where we have accept exception as E. And then I've given those exceptions that I've caught a name. I'm assigning them to the variable name that are boxed in red here, and then I'm referencing that, that exception inside of the code. So in this particular case up here, I'm catching a type error as TE, and then I'm printing a type error occurred, stir TE, so I'm outputting the string version of my type error in here. And just one second. Okay. Yeah, and then same thing goes down here for the value error, and then same thing here for the exception. Basically, you give it a name. This name doesn't have to be anything in particular. What I typically do is I just, name it according to the error type. So you'll see here, I have type error TE for the, capital letters there, value error VE for the capital letters there, and E for the broad exception there. So now when I actually run this code, I get that a type error occurred. So what happens here is that a type error was raised by this code. It was caught by this block, by this except block here, because I'm catching type errors in this except block. And then we see in the print statement, a type error occurred, colon, and then this is the message or the string version of that error here. It says unsupported operand types for plus, int, and stir. So basically it's saying like they both need to be ints or they both need to be strings. We can't have one of each. And that's the error that occurred there. So yeah, so everything here after the colon, this all came from this here where I cast my type error to a string. So I cast my type error to a string and it was converted to unsupported operand types for plus, int, and stir. And then again, we get process finished with exit code 0 because we caught and handled our exception. So we don't see a failure exit code down here. We see a successful exit code, which is 0. And then an important note, except exception should always come last. Otherwise, except blocks will never be reached. So if for whatever reason I had put my except exception as E up here, then we would have gotten to the exception as E block right away. We wouldn't have gone to the type error block at all. This is because these are evaluated in order. So the first one that's checked is, was the error an instance of a type error? If it wasn't, then was the error an instance of a value error? If it wasn't, then was the error an instance of an exception? It's always going to be, because as mentioned, every exception is an instance of any type of exception that can occur is an instance of the broad exception class. So if I put, except exception as E up here and then had type error, value error, whatever down here, then we would have only gotten to the except exception as E block because every exception is an instance of the broad exception class. So a type error is an instance of an exception class. It's really like a child instance of that exception class. So just keep that in mind. If you're going to use except exception, always put it last. Never put it before anything else. And I'll demo that at the end here. One sec. Okay, just took a note of that to make sure the demo of that at the end. All right, so exception handling continued. Say we want to actually fix the code and continue on in our execution. We can do that in our except blocks. So in this particular case, I have same code as before, x equals the string 10, and then I'm trying to print 9 plus my x variable, and then I'm accepting a type error here as TE, and then I print a type error occurred, x must be a number, x must not be a number, cast and retry. So here then I'm doing print 9 plus int, so I'm casting x to an int and retrying, and this will actually succeed. So what we see here is that an exception was raised here, a type error was raised by this code when this code was reached, and then I'm printing out a type error occurred, x must not be a number, cast and retry. So then in here I'm doing print 9 plus x cast to an int. So I'm doing print 9 plus int, and then in parentheses there the x that I want casted to an int. And then we see here that I get 19, in fact, because I've handled that error correctly. I've recognized that, the issue must be that it's not a number, so I need to cast it to a number, and I've done so here. And then we get that out, the correct output that we would have expected from this line of code had X been a number all along. So this is like true exception handling. And then we get process finish with exit code 0. What I was doing on the previous slide was I was catching the exceptions and making sure that they didn't cause the program to fail, but I wasn't necessarily handling them because I wasn't fixing the erroneous logic in any way. And alternatively, say we do want the exception to interrupt execution after adding our logging statement. We can use the raise keyword to continue to raise the exception to the user's level. So here I've just commented out x equals 10. So now x is not defined. When x isn't defined, we get a different error. We don't get a type error. So in my code here, my first except block, I'm catching type errors as TE. And in that case, I would print a type error occurred and then the string version of the type error. But if a type error doesn't occur, then I have a broad exception as E block. And in there, I'm printing out an unexpected exception occurred. I'm outputting the string version of that unexpected exception. And this is useful because, maybe I want to see what that error is so that I can update my code to have an except block that's specific to that particular error type and handle that as needed. And then, so I log that out there and then I raise E. So by raising E, here, basically what's happening is it's going to continue to raise that exception to the user's level. So the user will then see that error actually come through. The program will not exit with exit code 0, it'll exit with some other exit code. So when we run this code, I get an unexpected error occurred, name X is not defined. So that's the string version of my error here, that name X is not defined. And then in my traceback here, what you'll notice is that it calls out my file here, demo3.py, line 53. So I didn't capture the line numbers here, but this raise E is on line 53. And then it's kind of chaining together, where did that error originally come from? So it shows that my raise E is what was causing the error here. And we continue down in the traceback, and it's again from the file demo3.py, but it's line 48. So if we kind of count up from here, we have, this is line 53, 52, 51, 50, 49, and then 48. So this is line 48. So we see that in line 48, the erroneous code was print 9 plus X. So that's my erroneous code there. And then I get a name error. So the error that happened here is a name error. So it wasn't a type error, wasn't a value error. So even the code that I had on previous slides wouldn't have handled it correctly. But now I know it's a name error that occurred and name X is not defined. You'll notice this is the same string that was output up here. Name X is not defined. So this is basically like the string version of that function. So this is telling me that, I raised the exception on line 53, and then, but the exception originally occurred on line 48, which is up here where I was trying to print 9 plus X without first defining X because I've commented X out up here. So it's not actually defined in my program. And we get exit code 1 here because it wasn't a successful execution. We did in fact get an error that was raised to the user's level. It wasn't handled or anything. And that would stop the execution of our program. So any subsequent lines would not be executed, which oftentimes when we get an unexpected exception, if we're doing an exception block like we're doing down here, we don't want the program to continue because it's something that was unanticipated. So that unanticipated exception causes this, in an unanticipated exception situation, we typically want to raise that because we don't want the program to continue when some error that we didn't expect occurs. All right, and that's it for the lecture this week. I've provided some additional resources here at the end of the slide. So on W3 Schools, we've got information on classes and then some class exercises. I, again, strongly recommend taking advantage of these and taking the time to read through classes on W3 Schools and doing the exercises here. They cover things that I didn't necessarily cover in the lecture here, and they do a really great job of it. I highly recommend it. It's extremely beneficial to your learning. You'll definitely learn some new things. And they have, the code editor that I called out last week, where you can kind of where you can actually go in and play with the code yourself and see what things you can do to change it around and have different behavior than what they've defined in the pages that they have here. And then for learning about try excepts, you can learn about those also on W3 Schools. Again, highly recommend it. Unfortunately, there were no exercises for try excepts, so that's just something you'll have to kind of try and learn on your own, play around with on your own. For built-in exceptions in Python, I've given some documentation here. This is in the docs.python.org, so this is some true Python documentation here. This will give you information on the various different exceptions that you might experience throughout your programming career. You'll see them all at some point or another. They're useful to know about, but if you ever encounter one that you haven't seen before, it's generally useful to check these out. And then these are just the built-in exceptions for Python 3. There's always a chance that you might encounter a user-defined exception, so you might not actually see that in this documentation, but still worth knowing about. And then as mentioned, for user-defined exceptions, you can actually create your own exceptions. I didn't cover that here, that's out of the scope of this course, but if you ever have an exception that doesn't seem well covered by the built-in exceptions in Python, you can create your own user-defined exceptions. They're essentially like classes. So yeah, highly recommend looking into that as like some bonus material to read up on. All right, so really quickly, I wanted to demo, I want to demo what would happen here. So let's see, it was the note that I wanted to demo was this guy for except exception should always come last. So if I update my code here, I'm just going to update this to have the same code that was in there. So I had my x equals 10, type error. I'm going to accept a value error here. Print out a value error occurred, and then just cast to a string my value error. And then what I was saying here is, and then I'll remove that raise because that wasn't there. So I was saying here is that if I put this exception up here, you'll notice PyCharm kind of recognizes this is never going to be reached because exception is the broadest class of exception. So no matter what error occurs up here, it's only ever going to hit this exception block. It'll never get down into the type error block. So if I run this code here, if I run this code here, then we just get an unexpected error occurred, unsupported operands, and it's not unexpected. We know that that's a type error, but it's because I have my except exception up here. So it'll go in order of, it'll evaluate these in order here, essentially. So you always want your except exception block to come at the very end, because then it's kind of increasing or decreasing specificity, I guess. So this is like a type error is a very specific type of error. A value error is also a pretty specific type of error. And then exception is just a very broad error. And generally, as mentioned, what you'll want to do here is you want to raise your broad exceptions, because say you need to, say up here we had, let's see, my val. So my value is equal to this here. And then say I need to reference my value down here. Let's say I wanted to do like for I in range, my val print, let's just print I there. So if I don't raise E here, then what we're going to end up seeing is, sure, it seems like I handled my exception, but now I run that and I get an error here saying name error, my val is not defined. And my val is not defined because we got an error when trying to create my val up here, but then we didn't raise that exception in any particular way down here. So in this particular case, we'd want to, raise that exception so that we never get to that line of code where we're getting the my val is not defined. Instead, now if we run this, what I wanted to show here is this particular case where I comment that out. Now we get name error X is not defined, and then we raise that error here. But what we could do here is to get this to work is we could do my val equals 9 plus and then we would cast X to an int. And now we fixed our code. We've successfully handled the exception. We run our code there, and then our whole thing works. It says a type error occurred, unsupported operand types for plus, int, and stir, and then we cast that to an int. So now we have an int and an int, and now we've successfully created the myval variable here. And so now we can actually execute our loop here, and that's where we got the 0 through 18 output there because myval evaluated to 19, etc. Cool. All right, so for the assignment this week, here it is. So week 9 assignment, classes and exception handling. Your client needs you to create a program that will allow the creation of users in their backend system. All the work of saving this to their system is already in place, but they need you to create a customer-facing side of the application that will accept input from the user in order to build a user object that can be stored in their system. They provided the following program requirements. First, the program must elicit input from the user for populating the user object attributes. So we need to get user input here and refer back to the IO lecture if you don't quite remember how to get input from a user. And then for 2, the program must include data validation to ensure the values given by the user are correct per the property requirements. And we'll define the property requirements down here. And then for 3, the user object must be created using a user class. So you're going to need to create a class here. And the class should have the following properties and attributes, each following the mentioned requirements. So it should have a first name, and this cannot be an empty string. The user class should have a last name property, again, cannot be an empty string. So you need to, as mentioned up here for in point 2, you need to include validation for this to make sure that the first name and last name are not empty strings. For age, it must be a valid number between 18 and 100. If the user is under 18, stop execution. Look back to last week's assignment, or sorry, not last week's, week 7's assignment for how to just stop execution there. You could also maybe raise an exception here, a couple of different ways to do it, but we don't, your client doesn't want any user information stored for for minors basically. So we don't want to store information on minors. So if their age is not at least 18, or if they're older than 100, for whatever reason, they don't want to include people over 100. So they need to be at least 18 years old and at most 100 years old. So if the user is under 18, make sure to stop execution. And I guess same goes for if they're over 100. But otherwise, assuming that the value is between 18 and 100 inclusive, so we're going to include 18 and 100 in that range, store the value. The stored value must be in integer format. So yeah, not going to say anything more on that, just kind of hint, it needs to be an integer format. So a point here, include exception handling for the possibility that the user enters a non-numeric string for this value. In the case that this occurs, print, please enter your age in numeric format to the console and raise the exception so the program exits. So you'll need to make sure that the value entered is actually a number, because when eliciting user input, they could enter, say, a name there, or maybe they spell out 20. Say they're 20 years old and they spell out the word 20. That's not valid. We need to make sure that it's actually a numeric input. If it's not a numeric input, then you need to raise an exception. You need to raise the exception that would occur here. And there's a couple different ways to do that. I'm going to leave that to you to figure out. Then another property is an address. So it must contain 6 parts, and you must include validation here. So it needs to include an address number, a street name, a city, a province/state, a zip code, and a country. So I'll throw in a hint here. Hint, see split method for strings. So look into the split method there. This was mentioned in week 7's assignment. So hopefully you have some experience with it. You've seen it before. Google it if you're not sure. Look up the split method on strings to validate that the address contains 6 parts: an address, number, a street name, a city, province/state, a zip code, and a country. You don't need to validate each individual part. Like, it doesn't necessarily need to be a valid zip code. It doesn't necessarily need to be a valid country. You certainly can try to include that in your code. It's outside of the scope of the assignment by a long shot. But just know that, just make sure it has at least 6 parts. A birthdate's optional. So there's no validation required on it. A phone number, it must contain at least 10 digits. An email address, it must contain at least 5 characters, and 2 of those characters must be an at and a period here. So let me just bold these there so that it's a little more clear on what the characters needed to be are. And I'll also put these in. Oops, that made it harder to see. So you need an at symbol and a period in your email address, and at least 5 characters. So do what you must to validate that there. And then the user object in the user class, the class must have a method for getting the user object's full name based on their first and last name. So include a method in your user class that can return a full name there. And then once the user object is created, your program should print the following to the console. It should say, hello, the user's full name. Hint, you'll want to use the method mentioned in B here. And then it'll output, thank you for registering with the following information: first name, the first name entered for the object; last name, the last name entered for the user; the age entered for the user; the address entered for the user; and then the birth date if given. Otherwise, you'll need to output not provided. So make sure your code involves logic to output not provided if birth date wasn't given. And then phone number, the phone number here, and then the email address output here. So anything in these angular brackets should basically come from what was input from the user. All right, so unfortunately, I can't take any questions today because I'm just recording this lecture ahead of time because I won't actually be here on Saturday. Gaurav, though, will be attending our lecture time, and he'll be there to provide some demonstrations on classes and exception handling and answer any questions that you might have from this lecture or questions on the assignment here. If you have any questions as well, feel free to email me. I'll get back to you as soon as I can. Just know that I'll be out of town for basically this whole weekend and a little bit of the week on each end. So please be patient in waiting on responses from me. I will be busy, but I will get back to you as soon as I can. So thanks everyone for listening today. Please post any questions in the comments as well. Remember, I don't know if everyone's been reading the email, but remember, if you have a question, chances are somebody else has that same exact question and they just aren't asking. And you can help yourself and them out by asking that question. If you ask it on the YouTube video, then I can answer the question there, and then anybody who has that same question can see that same answer there. It'll help you because you'll have an easy reference to what the answer to that question is. It'll help other students because they can see answers to questions that they maybe feel uncomfortable asking. And it'll help me a lot too, because then I don't have to answer the same question for a number of different people. I only have to answer it once on that YouTube video and then kind of refer people to that answer there. All right. Thanks again, everybody. I hope you all have a wonderful week, and I will see you in week 10 for modules and packages. Please make sure to do the readings there and have the assignment 9 turned in before that time. Thanks.